Peace in YouTube. What's up? What's up, everybody? So today we're going to do something slightly different, but it's in line with the past couple of videos I've been doing. So if anybody's been following the channel, and you should, um, I've been doing grade level math problems, the hardest math problems, based on the hardest problems that are found on the New York State tests. So I'm in a bunch of educational forums, and I came along a bunch of questions that somebody posted that was pertaining to, I believe, if I recall, it was the summer packets given to students in China. I think it was on entry to sixth grade, but it could have been during the sixth to seventh grade. I believe it was entry to sixth grade though, and the variety seemed reasonable, and they're all kind of middle school level problems, 6, 7, and 8. Of course, they're good high school problems too. So what we're gonna do is jump through these. It's probably gonna take about an hour, I'm guessing, and let's just see where we can end up with that. Just again, I'm Greg from GregsTutoringNYC at gmail.com. I'm a tutor here in New York City, but I post a lot of free videos for you guys, and I'm just happy to give back to everybody. So with that in mind, let me jump in here. Let me get rid of that, and we'll just start up with some of the problems. Let me just make sure we're live before I start, because I've done videos where YouTube has messed up. I'm just happy to give back to it. All right, we seem live. I'll keep the chat up on my phone, although my phone keeps, I think it's not charging properly. So if you have any questions, just throw them out there. I'd rather this be interactive. I see a few people in the lobby. Welcome. Please subscribe and like to the channel. I'm always pumping out content, and likes give me encouragement, right? They also help the channel as well. So the more we can move along and post, I have already hundreds of videos up on here about a lot of math, and mostly math and ELA topics, and mostly pertaining to the SHSAT. These are kind of segue problems for the SHSAT. So, all right, with all that in mind, let's just jump in here. If you're catching us in the replay, try to give it a pause and try to solve it yourself, and then see what I've done on my solutions, okay? All right, so let me try to bring that up. Let me get my tablet going. I got a pen here. Am I good there? Yes, I'm good. So problem number 1. 2 gear wheels interact with one another. So we basically have this gear with teeth, if you will. Okay? And there's a second one. And they're not the same size. And somehow the gears are made to mesh to each other. One gear has 72 teeth. Okay? And the other gear has 28 teeth. So what we're going to read along each sentence and build up our knowledge as we're able to figure out things or not, okay? So you can imagine this might be in a clock, it could be in a car, it could be in 1,000 moving part things, okay? So we did the first sentence. There's 2 gear wheels that are interacting with each other, okay? Cool. One gear wheel has 72 teeth, the other has 28 teeth. Cool. If both gears have marked starting points, so let's say this tooth is colored in here, and this tooth is colored in there. Okay, so that's what they're talking about there. Marked starting points. And if you notice, I'm stopping even mid-sentence here to just try to understand what am I even being asked to do. Okay, so if both gears have marked starting points that are together when the wheels begin turning, so they're at a stop position, and then how many times will each wheel rotate between the two before the two marks meet again? So if this was, say, on an axle, and that was on an axle, and this one starts rotating this way, right? Then it means this way, this one is going to start rotating that way. Similarly, if this one starts rotating this way, then this one's going to rotate that way. So the question is, at what point are these 2 colored teeth here going to mesh up one more time? So if you imagine, if the 28 one does a full rotation, this one here is only gone about a third, right? Because if you count 28 teeth from here to here, might only be over here. So the question is, one of those two teeth going to mesh again? All right. So theoretically, this looks like an impossible problem to solve. But when you think of it deeper, especially in the context that this is being asked kind of at a middle school level, and you can talk about the proficiency that the Chinese are expecting if this actually came from a incoming grade 6 student summer packet. However you want to slice this, it's a math question. All right. So the question is, how do we approach this? What are they trying for us to get at? What you kind of need to do is dig through your cognitive toolkit and find out what mathematical concept they might be trying to get at here. Okay? The mathematical concept they're trying to get at is the least common multiple. So what multiple of 72 will be the same as the multiple of 28 at the same time? And it turns out that that concept is when the two teeth match one more time again, right? So how many times does that need to happen? All right. So that's what we need to do. We need to figure out the least common multiple of 72 and 28. Okay, so there's ways you may have been taught in school, like using prime factorization and so on. I like to use a technique where I'm just going to work on both numbers at the same time. My outside is basically going to be the smallest prime number I can think of at the time. In this case, it's 2. 2 goes into 72 36 times, and 2 goes into 28 14 times. Okay, do they both have any divisor again that might be a prime number? Yes, 2 again, right? So I get 18 here. 2 goes into 36 18 times. And 2 goes into 14 7 times. Okay? Now, this 18 has a divisor, but 7 has no divisor. So there's no common factor anymore between the two of those. So we're done. We're done. And if we were to do something like make an L right here, go down this here and across here, that's our answer. So we're going to multiply 2 times 2 times 18 times 7. Okay? So 18 times 7 is the same as 10 times 7, so that's 70. Right? 8 times 7 is 56. So we get, when we add those together, 126. Okay? Times 2 over here. So what are we going to get there? 252 if we double it. Okay? And times 2 again. We're going to double it one more time. So we get 504. So that's the least common multiple between those two numbers. All right? So all we need to do now is divide 72 into 504. Right? And when we do that, we get 7. And then divide 28 into 504 as well. And when you do that, you get, I believe the answer was 28. I'm not going to sit here and do the live multiplication for these. That's a waste of time. You should be able to do these without calculators, though. This is not super duper hard. The 18 times 7, yeah, it's annoying, but it's easy enough to break down. Okay, and we could have went over here and did 18 times 7 as well, right? And got the answer there too. So we don't really want to worry too much about that. So that's the answer. It's 7 and 28. Okay. Let me just give me 1 second because I calculated all these already, so I wanna put the answer on my screen so that I'm not making a silly mistake myself. And that's what some of these problems are. Is once you rip them apart, the question is, are you going to make a silly mistake or not? And if you do, can you catch it? And if anybody wants this PDF, just email me my email is floating across the bottom of the screen, right? The answer was the 72th gear had 7, and the 20th gear had 18 times. Okay, number 2 is we're going to do the same thing. So 3 identical cubes are placed side by side to form a rectangular cube. So let's pause and stop there. We're going to draw a cube. And this will be kind of behind in the, assuming it was a solid. And they don't tell us yet whether it's solid or not. Okay, so that's my sloppy looking cube there. 3 of them are placed side by side. That means they're smacked right up into each other. So if we were to try to, and when we do that, let me make this a little longer so that we can visualize this a little better. That's sloppy. Give me a second. If I bring this into thirds and kind of do that. Right, that's going to be my cubes. So there's going to be the behind the line over here. Okay, that's going to be solid because that cube is there. It's behind the thing there. This goes here, right? And that's going to be there. So that's what we had to do for sentence number 1 here. Just give me one more second to make sure we're live. Yes, we are. I see a few people in the lobby. Please feel free to comment and ask questions about whatever I'm doing. Okay. Whoops. Something just happened with my computer here. Okay, we're good. So it says the surface area of the rectangular cube, which is one of these, right? So we over here, this is just the cube by itself on the left, is 400. No, the surface. Give me one second. Okay, this I think this problem got interpreted slightly erroneously anyway, because it says the rectangular cube, and we call it rectangular prism. So be careful with that. Okay, I'm not sure why that's not going away on top of the word cube. I'm trying to erase that. Come on, get out of there. All right. Anyway, it should be rectangular prism. So 3 identical cubes are placed side to side to form a rectangular prism. I'll just put the letter P there. The surface area of the rectangular prism is 400 square centimeters, less than the surface area of the cubes standing together. So what are they talking about there? So what we kind of have to do here is figure out all the sides of what's going on, right? So on the normal cube here, we have 6 sides. All right. So if we were to smack the cubes together, theoretically we have 6 sides, right? Times 6 times 3, sorry. Just as 3 cubes. 3 6-sided things is basically what we're getting at. So technically, we have 18 full sides. Okay. The problem is whoops, I didn't finish drawing this. There was one there, and there's one there. So the problem is this side here and this side here, when we smack them together, right, they go away because it's saying they form a rectangular cube. So you could argue there's a wording problem with this question, and they may have been interpreted from when it was translated from the Chinese to the English. But in any event, that's what they're trying to say, that they're removed. Okay, so theoretically we're subtracting 2, but if you notice, if we just take this one here, this side of it is the wall for this cube A here, and this side of it is the wall for this B here, and it works the same way with this. This is the wall for B, and then if we consider this one C, then that's the C. So what we want to do is remove another 2, okay, and basically end up with 14 sides. All right, is really what it is, because we're removing 4 of them. So it turns out if it's 400 square meters less, that means the 4 we took out had to have been 100 square meters each, or square centimeters, sorry. Right? If they were 100 each, that means each face is 100. Well, the area of each face is a square, so that means the area of each face is 10. Okay? I mean, sorry, the length of the side, because 10 times 10 is 100. So that's our answer, 10. And you can work backwards through this too once you get the answer. So again, each face, each side of the cube is worth 100, because if we remove 4 sides and they're 400, then each side must be 100. Okay? This one's slightly tricky, but it's seeable once you get to kind of do that thing, right? So number 3. Let me just make sure we're still live, because YouTube always has a way to slap me around, and I'm talking into the ether. Okay, so 3 tends to be more of a classic problem. And it's just, there's a rectangular cubic box. So again, we would call that a rectangular prism. So let's just draw that. And it's key on a lot of these to try to visualize them. Don't do problems in your head. Do them on paper. Okay, and this is the so-called part in the back. Okay, so think of this like a shoebox, okay, or a tissue box, right? So a rectangular cubic box is made of wood, so all the sides are made of wood, okay? And theoretically, it's not telling us the thickness there, so that's theoretically another vague aspect of this, because if they like it was all made by 2x4s, that's not what they're going for here. All right, so let's just read the problem out, and then we can see where the math is going. So rectangular is made of, the length is 50, so let's call that the length in the front. Okay, the width is 40, so let's call this 40, and the height is 18. Okay, how many square meters of wood, so here's the fallacy of it, are needed to make this box? Okay, you have to kind of accommodate that the wood is conceptually infinitely thin. So really what they're asking us here is the surface area. What is the surface area of the box? Okay, and they kind of leave it open or closed whether the box has a top or not. So we're assuming it's a closed box, right? It's a shoebox with a top on, if you will, or a tissue box, because you have to pop out the top that way. So this is more analogous to a tissue box. So all we're doing now is the surface area, right? So if we do the front, which is going to be this, that's 50 times 40. Right? And that's equal to 2,000. We have 5 times 4 is 20. Add the 0 for here. Add the 0 for there. Right? This is no-brainer math. Let me fix that because this tablet doesn't write properly all the time. That's not an 8, that's a 0. Okay? And if that's the surface area of the front, there's also the back. So it's times 2. So we're going to get 4,000. Okay? So let me, so then we have the top and the bottom. So we're going to have the surface area of this now. Okay. Oh, wait, sorry. I just got the top and the bottom. Now we're going to do the front and the back. Sorry, that was 50 times 18. I said these in the wrong order, but we have to do his calculations anyway. We have 50 times 18. Okay. And that's going to be 900. We can do 18 times 5. You get 50. Plus 40 is 90 times the 0, and we pop that into there. And now we have the side. Which is here, the left side, and then the right side as well, okay? So that's 40 times 18. All right, so that's the nastiest calculation, the 40 times 18, but it's still possible. Okay, and we need to times 2 this as well. So that's going to be 1,800. And then 40 times 18, we get 4 times 10 is 4, 40, right? And 4 times 8 is 32, so we get 72. Add in the 0 here from here, so we get 720. We're going to double that as well, and we're going to get 1440. And now all we have to do is add up 9,000, 4,000, 1,800, and 1440. Okay, when we do that, we get 7240. And that's it, you're done with the problem. Reread the problem, make sure that's actually what you're solving. Okay, and then it makes sense. And of course, if you ask for units, everything was in centimeters here. So the answer is centimeters squared. We're not looking for the volume, we're looking for the surface areas all added up together. Okay, there's some other ways to solve this. We could have opened up the box in what's called the net and solved it doing different math. In this example, it's neither faster nor slower, nor more efficient or less efficient. You're still going to be doing a lot of those calculations. Okay, some things are faster than others. Some things are not. Okay, so 4 is definitely nastier than 3 was. And we really have to be more concise on how we visualize this. So let's take it again a sentence at a time. A rectangular piece of cardboard, stop. So let's visualize that. Has a length of 32 centimeters. So let's call this the length. We're just taking it a step at a time, a phrase at a time. Again, I see a few people in the lobby. If you have questions, definitely go ask them. Okay. Okay, so now we're done with this. A rectangular piece of cardboard has a length of 32 centimeters. Cool, awesome, right? Squares of 4 centimeters on a side are cut out of each corner. So if this is 32, this is 16, that's 8, so it's about right there. Okay, so that's a 4 by 4. That's what it's telling us. Each of these, right, squares of 4 centimeters on each side are cut out of the corner. So far, we have 32 centimeters and 4 centimeters. They're both centimeters. We don't need to do a unit conversion yet. Maybe we don't have to do it all. But that's something you always want to keep in the back of your mind if they're asking you to do that. So squares of 4 centimeters on the side are cut out of each corner. So we're gonna take them out of each corner. Okay, and they're all 4 by 4s. So we already know something about the width, right? If we call this the length, and this is the width, we already know the width has to be at least 8, right? Because there's the 2, 4, there's the 4 here, and the 4 here. Okay, and what we're going to also do is, if this is 4, and this is 4, then there's also another length inside of here that may or may not become important. Can you guys see what that length might be? It's going to be 32 minus 4 minus 4, 32 minus 8, right? Which is going to give us what? What's that going to give you guys? It's going to give you 24, right? Right, so 24 is this length right here. From there to there is 24. Okay, this may or may not be helpful. We're just trying to understand the problem so far. Okay, so then it says squares of 4 centimeters on each side are cut out of each corner of the rectangle so that the remaining piece can be folded into an open top box. Okay, so that means this part here since it's cut out, it's gone. Right? So what we're going to do is take this here and kind of flap it up so that this side meets that side, this side meets that side, this side meets that side, and this side meets that side. So what we're going to end up with is a 3-dimensional box, right? So in some ways, this illustration, once we cut the corners out, right? If you will, I'm going to put dotted lines here because this is going to be folded. This is going to be folded. This is going to be folded up. And this is going to be folded up. All right? So look what we have going on there. So again, we have another problem that's really resolving down into a rectangular prism. This is on the back. And I'm not necessarily drawing this to scale. I'm just drawing it so we can make sense out of it. So once we fold up the side, so this side right here might be that right there. Okay? So we know that's 4. The height is 4 then. Okay? This is the width. We still don't know what the width is. And the front, since we took the 4 and 4 off, we know this is 24. All right? So if the volume of the box is 478, sorry, why did I say, by the way, I have slight dyslexia and slight dysgraphia, so numbers don't always appear properly to me. The number is 768. So you guys have to spot me on this sometimes, which is hard because I'm trying to tutor math. And I have to look at numbers sometimes multiple times to make sure they're correct. So, so the volume of a cube or a rectangular prism is normally length times width times height. Okay? So far we know we have 24, right, times the width, and we know the height is 4. Okay? And they're telling us that that's 768. Okay? So what we need to do is use that to figure out what W is. Well, W is going to be equal to then 768 divided by this 4, right? If you do your algebraic stuff, times 24. All right, so we can probably cancel some stuff out here. If we, I don't know, can we put 4 into 768? 1, 4, yes we can. So 4 goes into 768. It goes into 7 once with 3 left over. It goes into 36 9 times. And it goes into 8 twice. So it may still not leap out at you guys that whether 24 can go into here. It can go in 8 times, but let's reduce this one more time. If we go 2 into 24, we get 12. And 2 into 192 is going to be what, 86? So we cross that out. We see we can go one more time. 2 goes into 12 6 times. And 2 goes into 86 48 times. So we can keep doing this forever, but you should be able to see that 48 divided by 6 is equal to 8. Okay? We're still not done with the problem. The problem didn't ask us what W was. The problem now asks us for the surface area of the original thing. Okay? So we know the length was 32, right? Okay? So the area of the cardboard is going to be equal to its length times its width, right? We know the length is 32. Okay, so far we've been calling from here to here W, but let's just call the whole thing now W because we're solving a slightly different problem. So it's going to be W, which was 8, plus this 4, plus this 4, okay? And that's going to give us 16. Okay? All right, and when you multiply that out, you get 512. And that's the answer. Okay? And by the way, you have a way to do this even in your head. You can go on the side and do 32 times 16 for sure. And you probably should, but you should also realize that 32 is the same as 2 times 16. And you should all know, right, that 16 times 16 is 256. So the problem reduces down to 256 times 2, which is doubling. So 256 doubled is 512, and you're done. Booyah. All right, so that's problem number 4. So it's taking a sentence at a time, trying to make physical sense out of it. Give me 1 second. My computer is stopping me from going to the right part of this. Okay, there we go. Okay, so this is kind of both the easiest problem and the hardest problem at the same time. So first of all, it's a word problem. So we have to do our normal stuff. We're going to try to rip this stuff apart. I'm having a problem centering this. So last year, the ages of both a mother and her son were prime numbers. So that's a prime number is a number that's divisible by 1 in itself. Okay, you should all know that at this point. So this fact may or may not help us in the solution. This year, right? So there's 2 different kind of things being compared to something from last year, right? And this year. Okay. So then they're going to ask us, what is their age this year? Okay. So you want to make sure that you're getting that to make sense. So it's telling us that the mother times the son, right? The product of their ages is equal to 532. Right. So what we need to know is, whatever that is. Let's say it was 7 and 8. Right. It's not, but we're just trying to understand the problem still. So if it was 7 and 8, it's saying last year. So we're talking about when it was 6 and 7. Right. It says their ages were prime numbers. So that wouldn't work here. So what we need to do is figure out the factors of 532. Okay. So that's what makes this problem hard. So let's do the factor pairs. It's 1 and 532. Okay. 2, you should all know that it's divisible by 2. 2 and 266. Okay. By virtue of that 266 is still divisible by 2, you should know that one of the choices is now still 4. Right? Because if I can have 266, that means I need to double what's on the left side here to still get the 532. So you know for sure that 4 is a choice. Okay? So when you divide 4 into 532, you're going to get 133, which makes sense. You're doubling the 2 and you're halving the 266. Okay, so now the question is 3 a divisor? Okay, you should know your divisibility rules. That a number is divisible by 3 if the sum of its digits is also divisible by 3. And you can repeat that step if you need to. So 5 plus 3 is 8, plus 2 is 10. So 3 is not a divisor. Okay? So this is where it starts getting ugly because like what might be next? Okay? And by the way, I'm gonna squish this up because I don't want to smash into problem number 6. So I'm gonna rewrite the 4 here. Let me get rid of that. Okay, we know it's not 5 because 5 can only go through numbers that end in a 0 or a 5. Okay, is it 6? No, it won't be 6. Because if it was 6, the number has to also be divisible by 2 and 3. So it's not. It's only divisible by 2, so 6 can't go into it. How about 7? It turns out that 7 works. So 7 goes into here 76 times. Okay? What you need to do when you do this factor pairs is get it so that the two numbers, the last two numbers, are close so that if you get the next divisor, the columns are going to flip. So what happens is we try 8, 9, 10, 11, 12, 13, 14, and you can try those. When you finally get the 14, you get another hit. So 14 goes into here 38 times. Okay, this problem could make use of a calculator to make this faster. Because what you have to do is like divide 11 into it, divide 12 into it, divide 13 into it to try to get those things there that way. All right? Get the phone call. I get a lot of messed up phone calls. And then it turns out 19 is the next one. So it's kind of some busy work to this problem, if you will. And that's the other thing to this problem. If you skip a factor, which turns out to be the answer, you're never going to get the answer. So when you create the factor pairs, you must incorporate every single possible one. Okay? So now that we have the factors, we know that their ages are not going to be 1 and 532. It's not going to be 2 and 226. We know it's not going to be 4 and 133. It's most likely not going to be 7 and 76, but we'll leave those 3 as the last choices. So if we're going to look at the last year's numbers, right? So a year ago, it would be 6 and 75. Okay? They're not prime numbers, so no good. Okay? If we look at 14, we're going to get 13 and 37. Okay? They're both prime numbers. And just to be sure for the last one, we get 18 and 27. Both of those have divisors, so that's out. So here's our choice, and it wants their age this year. So this 532 said this year the product was. So that's our answer. It's the 14 and the 38. All right? All right, so that's the end of the word problems. The rest are basically solving small arithmetic expressions, which can be annoying in their own right. And I wrote them all on paper just before this started, just in case I make a goof up live. Right? So this 0.15 is 15 hundredths. Okay? 9/20ths, if we make that hundredths, right, we're going to multiply the denominator by 5. So we're going to multiply the numerator by 5. So we get 45. Okay? This, I read 49. Why did I do that? Okay, that's going to be added, and it's in parentheses. So we get 45 plus 15, we get 50, so we get 60 hundredths. So what we have is 6 minus 60 hundredths is like that, okay? And we can throw away that 0 if you want. And anyway, it gives us 5.4 then. And that's it, we're done. Okay? So you don't need a calculator to do some of these. And these are not really trying to demonstrate your use of using a calculator. All right? So be careful with something like that. Okay, so B gets a little stranger because it's using 2 decimal numbers at the end. And then this kind of, you could argue it's a weird fraction. All right? And by the way, you guys should know your fractions. You should know what a half is. You should know what a third is. You should know what a sixth. I'm talking about the decimal form of it. You should know a 12th. You should know 11th. You should know a ninth. You should know 1/8. All these things like that. So that means you should know like what 3/8 is. You should just be able to rattle these off. Okay, because it's your mathematical prowess and astuteness, and you don't want to be bogged down in a problem because it said 3/8. That should just, you can be like 12 times 10. You should be able to pull that up in your head, at least get it faster than actually doing 8 divided into 3. All right. So we have 8.15, right, minus 6.9. Right, we can do these two first if you want. And I want to. We're going to subtract those. Technically, we have a 0 here then if you want, because it's still the same value. 5 minus 0 is 5. We can't borrow from the 1, so we're gonna borrow from here first. We're going to get a 2 and that. So we get 1.25. Okay? So we need to add that to 7/16. So if you know what a 16th is, that might be often handy in a lot of cases, but in this problem it doesn't help us too much because there's 7 of them. And to try to do that in your head or even on paper, because it's 0.0625 times 7, that's not really going to help you. All right, so what you want to do is 16 divided by 7. So your goal in this is going to be to try to get a decimal fraction out of this as well. All right. And you're probably going to have at least 2 decimal places there. All right. So 16 goes into 7. No, it doesn't. So we bring up the dot, right? 16 goes into 70 4 times. Because 16 times 2 is 32 and times 2 is 64. So we're going to get 64 here, right? We're going to subtract 70 minus 64 and get 6. We're going to drop down this 0. So we already knew 64 times 4 is 64. So 16 times 3 must be the next one. Okay, 60 minus 18, right? 60 minus 48, and we're going to get 12 left over. Okay, we're going to add another 0 here because we're not done. So 16 into 120. Okay, so you have to experiment here. You do 16 times 6 and you get 112. That might be good. You're going to do 16 times 8 and you get 128. So it turns out 16 times 7 is 112. You get 8 left over. You're going to add another 0 and drop that down. And then you have 16 into 80. Okay, and it turns out that's 5 times. 5 times 10 is 50. 5 times 6 is 30. 50 plus 30 is 80. So that's what we're going to get. So now that we have what 7/16 is, we're going to add it to this here. Because that was this 8.15 times 6.19. Okay, so we're going to add 0.4375. If you want, you can add these 2 zeros here, right? So that's 5, that's 7, that's 8, that's 6, and that's 1. So we get 1.6875. Oh yeah. All right, so I'm going to erase that so it's not blocking the next problem. So this just become tedious. It's about converting mostly these are about converting the fractions into decimals to be able to do it. It's also about trying to look at what some of the numbers that might work in your favor are or aren't. Okay, so this is 7.5 plus 3.7 minus this. So to me, this works in my favor. That's 3.7 minus 3.2 is 0.5. Okay, because I'd rather do that and add this to here, right, and get 8. So you see how fast that was? Otherwise, I have to do 7.5 plus 3.7 and then minus the 3.2. So see what can leap out at you as the more natural arithmetic thing to do. And then all we have to do is do the 8 and 5/6. Okay, and we're subtracting that, by the way. So the answer is going to be 8 and 1/6. And this problems didn't define whether all the answers had to be in decimal or not. If it is in decimal, then we get 8.16, and the 6 repeats. All right. So depending on what they're looking for here, that's what it would end up being. All right. Let me just make sure we're still live, so I'm not talking into either. I see there's still people in the lobby. Please ask questions. Please subscribe. Please like. Okay. Okay, so D has some of the same kind of thing. So don't add 3/7 plus 2.16, because if you look at it, you can see that 3/7 plus 4/7 is 7/7. And of course, that's equal to 1. All right, so then it becomes the point of adding 7.84 plus 2.16. Right? So when you do that, you get 10. This adds up to 10. So the problem comes down to 1 plus 10 equals 11. Okay, E has the same things. So I said before about converting things to decimals, but in this case, maybe or maybe not, that's the right thing to do. All right, so first of all, let's just combine the fractions and see what leaps out. So to add the things in the parentheses here, okay, it turns out that our common denominator can be various things, but to me, I'd like it to be 30. Okay, so 5/6, that's times 5, that gives us 25 here. And 4/15 is 2/30. Okay, so when we combine these, it's 2 minus 27/30. Right? Let me see. What did I do here? Oh, sorry. This was 4. This was 4. So when I doubled that, it should have been 8. I made an error. What's key is to be able to fix it. So we're going to get 2 minus 33/30. Okay, 33/30 is the same as 1 and 3/30. So we end up, when we subtract 2 minus 1 and 3/30, we get 27/30. And we can divide the top and the bottom of this by 3 and get 9/10. And again, I don't know the premise of these questions. That might be fine, or 0.9 then, okay? or 0.9, depending on what you're being asked to do or whatever. Okay, then problem number F is more or less along those same lines. What I'm going to do is convert this into 0.75. Okay. 4 25ths is 0.16, right? Because we get 16 over 100. So this is 16 hundredths. Okay. So since this is subtraction, I'm going to look at these two because that's what leaps out at me. And I don't have to do this, but it's 0.16 minus 1.76. And when I subtract those two, I get minus 1.016. Okay, so to me that 0.16 leapt out. Sorry, compared to the 0.17. Okay, so what it's reducing me down to is I have the 1.195, right? This is gone now. This is gone now. And now this minus is going to apply to there as well. So this is minus 0.075 at one point as well. All right. But in any event, now we have all these decimal numbers here. And once we do that, let's see, what did I do here? I'm going to take this and subtract it from that and get 1.206. And then it turns out that 1.206 minus 1.016 is 0.19. Okay? And that, I believe, is the answer. Okay, there's no answer key to any of these, so if anybody sees an error in something I've solved here, please correct it. You can email me. You can leave a comment on this video. Okay, and then there's a few more. They're fair. Some of these were fairly simple, so let's just go over them fairly quickly. This is a quarter minus 2/5, so let's convert these into 20ths. Okay, 2/5, that times 4, so this is going to be 8. Okay, 1/4 times 5, so this is going to be 5. Okay, so we get 13 20ths. Right? So 1 minus x equals to 13 20ths. Okay, we can subtract 1 from both sides, and we end up with minus x equals minus 7 20ths, or just x equals positive 7 20ths. And again, I don't know the nature of these problems. I don't know if a fraction was good. So this is also the same if they want a decimal. This is also the same as 3.5 tenths. Right? We just divide the numerator on the bottom and the denominator also by 2. Whoops, by 10, not by 100. And that's the same as 0.35. Okay, so the answer is either this or this. We don't know which. Okay, B is kind of the same thing. So 5 minus a half gives us 4.5. Okay, if we add the 3.875 to both sides, $785. I said 875. Sorry about that again. my brain sees stuff, and I have to sometimes look at it multiple times, which goes to show you that you can still solve these things through adversity. When you add these up, you get 8.285. Okay, the last one's nasty because it has all this 8.285. Okay, C. We want to subtract 8/9 from both sides, and we're just left with x equals that thing. Wait a second, I don't know what just happened here. I clicked on the wrong thing somehow. So we're going to subtract 8/9 from both sides. That goes away. So the common denominator between 12ths and the other one is 36s. So 11/12 times 3 is going to give us 33, right? And 8/9 times 4, so that's going to give us 32. And that gives us 1/16. Sorry, 1/36. So again, if whoever wrote these questions really wants that into there, you actually have to do now 36 divided into 1. And that gives you 0.027, and the 7 repeats. All right, and then we come to our last problem, finally, is we're going to do 8.75. We're going to add 4.93 to both sides. So we're going to have 8.75. Plus 4.93, right? So if we add those up, we're going to get 8. 9 plus 7 is 16, 6. Carry the 1, 8, 9, 13. We get 13.68. That's what 3x is equal to. So we're going to divide by 3 to get the value. 3 into 13 goes 4 times. Carry the 1. 3 into the 16 goes 5 times. Carry the 1, and 3 into 18. 6 times 3 is 18. So the answer is 4.56. And we're done. We got it. Okay. All right. Hopefully everybody had some fun. I did. And I'll resume the grade 7 stuff probably the next time. This was just a little fun to branch off on. Again, I'm Greg from Greg's Tutoring NYC. Hopefully everybody's having a good weekend. Yeah. All right. And again, if you guys want to do this in the replay, just pause it and you'll get those parts. All right, everybody. Peace.